Here again, and today I want to make a video just on the understanding of C++, or another video to help make sure that you understand some certain things in programming that are very important in my opinion. So the first thing I'm going to show you guys is an example, and I'm going to just tell you ahead, it's on purpose to confuse you. It's purposely confusing you, but I just want to show you guys, and then I'm going to later talk about why this is going on and why everything is going on. So what I'm going to do here is I've got this C++ file called testing, and don't worry about any of the includes really, but really what I'm going to do is I'm going to have an if statement. And this if statement is going to be just like that. And sorry, it's going to be just like that. And I'm going to have just a basic cout in this print statement. Cout. Let's do hello. And a semicolon. Okay? And now, one thing I do need is I need a condition inside this if statement. And what I'm going to do this time is instead of, maybe a condition like if 1 is greater than 2 or something like that, I'm just going to say if 1. And now my question to all you kiddos, or people who are watching this video, is will this program run? When I build it, and when I build this program and run it, will I get an error, or will my program print out hello, or will it run but not print out hello? So what I'm going to do here is I'm going to run the program, and I am going to actually run it, and as you can see here, it did run, and it did print out hello. And now I want to talk about why that happened is. Well, see, the thing, and the reason because of this is because what I want to, let me print out one other thing first. What I want to show you guys is that true and false values, the true and false variables actually have two numbers. They have, the first variable they have is, the first variable or thing they refer to is 1 and 0. So what I'm trying to say is, to make sure this is a crystal clear explanation, is that true and false actually represent numerical values. True represents, let me see if this works. True represents, I forgot to put a /n. True represents /n. I mean, not /n, that's what I need to put in this program, but true represents 1. It represents 1, and let me print out false as well. And so let me do an indel here. Let me print out these values. Okay. So now that I've run my program, oops, my bad. But anyway, you guys get it. So what I'm saying is that 1, if I print out true here, which you may not think of doing, but if you do, it gives me 1. If I print out false, it gives me 0. And what this means is that essentially true and false are aliased to two numbers. True is 1 and false is 0. And the reason and a good way to think about this is what they're doing is they're making this a binary representation. If you don't know anything about binary, I highly suggest Googling, but it's a language with only zeros and ones, and zeros and ones can be used to represent all known numbers, which is the only thing a computer knows. On the very lowest level of a computer, everything is represented in binary. So somehow we must map everything we do in a program to binary, to ones and zeros. It's pretty magical, is it? And so when I do a Boolean condition, when I say if 5 is greater than 2, I'm either going to return a 1 or a 0. And what happens there is, let me just do another cout quickly just to show you guys another thing. I'm just going to print out end right here. I'm going to make this if statement 0. So I'm going to say, instead of saying if and then true, I'm going to say if 0. And then I forgot a semicolon here. I'm going to print this out. Okay? So I get end. So as you can see, my if statement did not execute and nothing got printed out there. And so I am allowed to print out, it is saying 0 is getting 0 is getting mapped to false because they are represented in binary as the same value. 0 is false and 1 is true. There are actually other values that can be true that I will get to in a second. So that's pretty cool. So I just want to represent I just want to show you that true is actually can be mapped to 1 and false can be mapped to 0, or they can be thought of as mapped to 0. And really everything in programming has to have and has a numerical representation that you can use. So that's pretty cool. Something I also want to show is that in C++, actually true, if I put any number besides a 0, it will be it will take the Boolean arguments will take it as a true value. So what I mean is that true is any number that's not 0. So let me just show you guys. So I'm going to do 23 right here. I'm going to run this program, and I get hello 1 0, and then I get end because I didn't do an endl. And sorry, I've switched to a new keyboard design, and I'm not actually that good at it. So there you go. So I can run that, but also I want to just prove everything to you. So I'm going to do -9, and I'm going to do that. And let's try -9.1. I've actually never tried that before. And I run this program again, and hopefully everything's okay, and everything's all good. But then again, if I put 0, then it will be false again. So any number but 0 is 0. So that's pretty cool. So true and false have numerical representations of 1 and 0, but even though I showed you guys that anything but 0 is interpreted as true, the actual value of just saying true, like I do right here, is 1. And false is 0. False is always 0, but true in Boolean arguments can be interpreted as anything but 0. So that is good to know. Okay, and so now I'm going to just put this down a little bit, and I'm going to show you guys something else. Well, actually, I'm going to get rid of this. So I showed you guys that. So now I'm going to show you guys something else, another kind of particular thing. So I'm going to have a char A, and I'm going to set it equal to A. And so that's kind of cool. And when I have that, I just have a basic char, and I'm going to do something that maybe you'd usually do with a number. I'm going to increment it. So I'm going to take this char, and I'm going to increment it. So I'm going to see out A. And I'm going to see out A and then print it out A. So I want you guys to think what's going to happen. Is a segfault error going to happen? Am I going to be able to run my program? Am I going to be able to run my program, but some weird error will happen, or will I just be able to run my program? So I'm going to run my program, and as you know, my program did execute without any errors, and instead I got B. And so in some kind of weird way, if someone maybe asked you on like an SAT or some weird test, what's A plus 1, you may say B, right? Well, what's happening here is, again, let me do something like this. I'm going to print this out, and then I'm going to print out, what I'm doing here is I'm printing out A as an integer, and it for some reason thinks the char of B is 98. And I'll get back to that. But first, I will want to cover this. So char is a character, right? A, B, C, D, E, F, G. And what I want to show you guys is that what is happening here is when I assign a char to A, I'm actually the char value is being looked up in something called an Ascii table. And an Ascii table is what the letters are on your keyboard, or the representations are on your keyboard. And these guys got together several decades ago, and they decided on something called an Ascii table. I highly suggest you Googling it. I'll have links in the description. And what an Ascii table does is they decided on numerical values to represent all of these characters. So they decided that B would be 98 and A would be 97. Let me show you guys if I comment this out here. I'm going to get 97. And so actually the alphabet, the lowercase alphabet, starts at 97, and then it goes 98, and then it goes to 97 plus 96. Something I also want to show you guys is that all the characters are different. Any character that's even slightly different is a completely different mapping. So for instance, capital A is mapped to 65, and then capital B would be 66. And so basically these characters have mappings to numerical values as well. Like I said, the key lesson here is that everything is a numerical value, which is important to remember. So what I can do is I can perform mathematical operations on these chars, and we'll treat it as it will treat it as the number in the lookup table. But when I print it, it will say, oh, the type of this is char, and then print it out as a char. So there you go. So I can perform mathematical operations on chars because they're, again, a kind of a table looked up system, or they have numerical values. So like B is 66, and space has a value, and CH and R, and weird symbols like these brackets have values as well. Let me try doing that here for a second. So I'm going to assign it to that, and I'm going to print out this bracket, and the value of the bracket is 126. And I'll post a link to an Ascii table, and you can look all these up. And so that's kind of cool. So again, the lesson to take away from this is everything is numerical in C++. So now I want to show you guys something I can do. So now that we saw that, I'm going to make an integer b, and I'm going to declare it to true plus a plus 12 plus 34.3 semicolon. Okay, and then I'm going to C out B, and then I'm going to run it, and we're going to see what happens. So what did I get here? Well, let me get rid of this, or comment it out, because that got jobbled up in it, and I got 144. And so what happened is that, first of all, I have true, which is 1, and then I have true, which is 1. I have A, which we discussed is 97. I have 12, and then I have 34.3. But since it's an int, the decimal gets cut off. So 1 plus 97 is 98, plus 12 is 110, plus 34 makes it 144. So so it is possible to add all these things together, right? All these things have a mapping, and their numbers are looked up, and then it's added to an integer just like nothing happened. So I could add, chars, I could add all these together, and I would just get another numerical representation, which is just something to think about in C++. You would never need to use a statement like this, and if you are doing something like this, you're probably doing it the wrong way. Actually, you are doing it the wrong way. There should be another way to do it. But I just want you guys to understand, this is a good exercise for me in the beginning, because it helps you understand that everything is a numerical representation in C++ in the base types. I want to note also, I do this with, these are the basic types, so all the basic types are represented in integers, just to be crystal clear. And I cannot do this with objects, so I couldn't just add a string using the double quotes. There are other ways. There are ways you can add strings, like I could do a string plus another string, but that is a different principle with objects called operator overloading, which I'm not talking about in this video. But I just want to show you that all these basic operators are represented numerically, and so you can combine them numerically in some kind of strange way. So I'll have a link to the Ascii table. I advise taking a look at it, and I hope you guys enjoyed this video.